Hello and welcome to this mathematics training DVD brought to you by 3D Buzz. My name is Steve Twist and I'm going to be your instructor throughout this training series. This DVD, focusing on vectors, is the third in a series of DVDs covering mathematical theories and techniques that I believe are essential knowledge for anyone who works in computer graphics or programming. It's going to build on the topics we covered in Volume 1 of this series, where we looked at analytic geometry, and Volume 2 of this series, where we looked at trigonometry. Now, vectors are quite a recent area of mathematics, dating back only from the 19th century. Now, you may think to yourself, 19th century is recent? Well, in the world of mathematics, anything within the last 200 or so years is actually considered recent, given that a lot of the concepts and theories that we still use today date back thousands of years. But despite being a recent discovery, vectors are incredibly powerful, and they have facilitated the development and advancement of theories in physics, engineering, computer graphics, programming, and many other areas of research. So they're incredibly useful and incredibly powerful. Now, the key to vectors, as you'll discover in the next video and then throughout the rest of this training DVD, is that they allow us to represent a direction. Whether that direction's in our 2D space or our 3D space, they allow us to represent directions. And because of that, vectors can be applied to pretty much any area of computer graphics. They're used in modeling to represent surface normals, for example. They're used in rigging quite commonly to represent the axes of rotation that we have in a character, for example. They're used extensively in shading and lighting calculations. We might represent the direction of light, or the direction of a reflection, or the viewing direction of the camera into the scene. We may represent all of those using vectors. And those are just a handful of examples. Vectors are fundamental to any program that involves some form of 3D or even 2D space. And they're so fundamental that I personally think they're one of the most important, if not the most important, area of mathematics that concerns computer graphics. And they're certainly extremely helpful when programming in general as well. Now, this DVD is really split into two sections. The first few videos focuses on 2D vectors, introducing a number of key concepts and techniques, including what vectors are, how we find the magnitude of a vector, vector addition and subtraction, the multiplication of a vector by a scalar, what unit vectors are, and what position vectors are. However, by introducing these theories in 2D Cartesian space, we keep them just a little bit more manageable. So once we've covered all of those theories, we're then going to move into what I'd like to think of as the second section of this DVD, where we're going to be focusing on 3D vectors. So we begin by going back over all of our 2D theories and extending them so they work in three-dimensional space. From there, we're going to dive into some more advanced and complex concepts and theories which utilize 3D vectors. And these are theories such as the dot product, the cross product, the vector equation of a line, and then wrapping up this DVD, we're going to look at how we can find the perpendicular distance of a point from a line by utilizing the vector equation of a line and some of the vector theories that we've seen in this DVD. Now, all the way as we go through this DVD, we're going to see how these theories can be applied to solve problems that relate to computer graphics and to programming. As with all the volumes in this training series, the theories and proofs presented in this DVD are loosely based on two maths textbooks that I found to be useful in my studies, combined with my own personal experiences of having worked with those theories to hopefully present them in a more intuitive and friendly manner. The first of those books is Mathematics for Computer Graphics, 2nd edition, by John Vince. It's published by Springer, and its ISBN is 1-84628-034-6. The second is Mathematical and Computer Programming Techniques for Computer Graphics by Peter Komnenos. It's also published by Springer, and its ISBN is 1-85233-9020. Now, whilst these maths textbooks do provide a wealth of very useful content, I don't necessarily recommend that you all rush out and go and purchase them right away. Being textbooks, they are quite formal and they are a little bit dry. Komnenos' book more so than Vince's book. So whilst they do contain a lot of useful information, my advice would be that with the essential topics that we're going to cover together in this lecture series under your belt, you should have no issue with continuing your studies through the wide variety of free mathematical information that's available on the internet. So if you simply search for the topic you're interested in, you're going to be able to find a wealth of information available out there, which should hopefully all make sense once you have a good grounding in the principles and theories. Now, obviously, there are different viewers who are going to be watching this lecture series, and they're all going to come to this lecture series having different backgrounds and different amounts of prior mathematical knowledge. And of course, everything in mathematics builds on everything else. I have therefore chosen topics that I believe to be essential foundations for working in computer graphics and programming. So whilst I'm trying not to go over extremely basic ground, there is the possibility that some of the topics I cover you may be very familiar with. On the other hand, there's a possibility that some of the topics are going to require previous knowledge that you simply don't have. In the first case, the way this lecture series is structured, with each topic encapsulated in its own video, you should be able to skip any topics that you feel you are already very comfortable with. In the second case, if you find yourself unable to follow any of my logical progression through one or more of the videos due to a lack of the required background knowledge, my advice would be to either have a search online for information, maybe covering the area that you're unsure on, and then watch the video again, or if that doesn't help, simply visit 3dbuzz.com and post your questions and queries on the forums. Myself, or many of our other knowledgeable and helpful members, will be very happy to help you out, to point you in the right direction, and hopefully be able to aid you in your understanding of the topic. So before we get started with our first lecture on this DVD, I want to briefly explain the overall structure that most of the videos will take. Firstly, the topic is going to be introduced, and I will discuss what is it that we're actually covering in that particular video. Next, I will often validate that choice of topic, letting you know why I believe that the topic is so important and useful, and if appropriate, how it applies to computer graphics and programming. After the introduction, we're going to move on to the theory of the topic, where the topic itself is taught and some example questions and scenarios are worked through. So that's the core of each video, each lecture. And then finally, at the end of the lecture, I will set questions for you, the viewer, to work through on your own. Now, after each question is set, you're going to have the opportunity to pause the video and attempt to answer the question yourself. Then once you unpause the video, you'll see me work through the answer on the whiteboard. Thus, that allows you to check your answer, or if you got stuck as you were trying to work out the answer on your own, it allows you to get assistance on whichever points you got stuck on. So that's going to get this introduction out of the way. So now that it is out the way, let's dive into the first lecture of this DVD. Thanks a lot for listening, everyone.